Good morning, everyone. Thank you for joining us today. My name is Kevin Curry, and on behalf of the Mobility Development Group, I would like to welcome you to our webinar on end-to-end security for IoT and M2M, presented by Zaid Saeed Hussein, otherwise known as Z, of ARIS Communications. Before I introduce Z, I would like to remind everyone to please submit your questions via the Q&A tab on your screen. This is located on the right-hand side. We'll be able to answer your questions at the end of the webinar, time permitting. If your question is not answered live, we will follow up with you via email. Now I'd like to introduce our speaker, Zaid Naeem Hossain, Z of ARIS Communication. Z is the CTO of ARIS, and he is responsible for the architecture and future direction of ARIS networks, development programs, and technology strategy. He joined ARIS in 1996 as Vice President, Engineering, and member of the founding executive team of ARIS. Z has over 35 years of experience in semiconductor, computer, and telecommunications industries, including product development, architecture design, and technical management. Prior to joining ARIS, Z held senior engineering and management positions at Analog Devices, Cypress Semiconductor, CAD National, ESS Technology. Z is the chairman of the International Forum for ANSI 41 Standards Technology, IFAST, and is on the board of the Mobility Development Group and the IOT M2M Council. He holds a bachelor's degree of science in computer science and engineering from the Massachusetts Institute of Technology in Cambridge, Massachusetts. We'd like to welcome Z for being our speaker. Z?
Thank you, Kevin. Appreciate the introduction. Folks, let's get started, and then we will have any questions that you might have, and I'll address the questions at the end. So the title of my talk is End-to-End Security for IoT and M2M, and I'm going to give you the following agenda about what I will cover. Just a few slides on ARIS, what we're up to, who we are, what we do, and then give you an analyst's view of the world of IoT security. This is a gentleman who has been focused on this issue for a while, and he put together some slides for me, which I will present on his behalf. Then talk about some security basics and overview, and then some of the things that we are doing for IoT security, some of the thoughts that we have about what can be achieved, and then hopefully we'll have some time for Q&A at the end. So diving right in, who is ARIS? We are a M2M IoT technology provider. We have about 175 people. Half of us are in engineering and operations, and we provide three basic capabilities, what we call enterprise IoT connectivity for any company who is looking to enable their products for providing information from remote devices out in the field or selling such services and product to end users ultimately who might want to have such applications deployed for them. We also provide our technology to network operators as a service, as a platform, and we've been quite successful at that in a number of different areas. And finally, we are providing some analytics. Previously, we used to, in the early days, we used to simply do connectivity, and now we're worrying about the content on behalf of our customers using a cloud-based solution. We're headquartered here in Santa Clara when we have operations in the UK and India, and we'll be operating, have services available just about anywhere in the world at this point. Our network operating centers are in San Jose, Vegas, and London, and we have a new one going into India. Here's one slide snapshot of our system. Right at the bottom, you see our AirConnect cellular connectivity services. This is what we do for transporting information in the M2M IoT applications that are deployed on our network. It is a cellular service, although people are doing hybrid applications as well using other technologies to feed into the cellular service that we provide. Above that, on the left, you see our Air Core network. We design and develop our own core network for cellular services because it gives us some specific advantages. It's optimized for M2M, and of course, it does all three technologies, GSM, CDMA, and LTE. That's one of the distinguishing features about us compared to some of the other providers, is that we can provide capabilities all the way from 2G, 3G into 4G across all three technologies, basically GSM, CDMA, and now LTE. Above that is our portal for managing the devices out in the field, and finally our Air Cloud, Air Voyance, both our storage and application platform as well as the analytics system that people are now using. All of that is supported by our billing systems and our next generation let me call it this way, the ability to get started very quickly for M2M IoT services that we call NEO. All of this is accessed through APIs, and every application that is deployed on our system is generally using an API to access these if they don't use our portal directly. All right, well, those are the two slides on ARIS that I wanted to talk about, and then let's just dive into the details of the presentation itself. This is a diagram put together by Beecham Research that shows how incredibly the world of IoT is expanding into various areas. Obviously, I'm not going to go through every little tiny item displayed on this slide, but you can see it's having an impact on the inside arc there. You'll see the service sectors where it's having an impact, ranging from energy to consumer and home applications, industrial applications of various kinds, IT networks, all kinds of stuff for which there are applications, and then where these applications are being deployed and used, and the devices that support these applications. M2M and IoT is having a tremendous impact on the world in general, and the things that are taking such applications by storm is the fact that there's data out in the field which can be brought in to gain some insight as to what is possible, what is available, what can be done in these various market sectors. So there are various large concepts such as smart city that incorporates various little pieces from inside this diagram that Beecham Research put together. But if you look at it as a whole, each of those individual applications has some security implications that need to be thought through. So Beecham Research put together this diagram to show what can happen, and I think it's a pretty interesting little diagram over here, that if you look at an application from the perspective of the things that can attack, you have the inside, which is the buildings, the energy, the applications, the solutions, all the way through to the edge devices. And there are physical intrusion possibilities. There's people who are implementing cyber warfare against some of these devices. And then there are the new applications that are coming along, typical M2M applications that are coming along. And the current applications tend to be more based in the IT and network security area, although there are going to be new applications that come along and break some of these silos that exist today, the separations that exist today. So in this diagram, there's an attempt to show that each of these places is an internal interface of some sort that can have an appropriate vulnerability. And there are varying security and threat levels that that attacks can take place with. And there's varying kinds of security solutions you can provide based on the cost of providing those solutions. And the fact that these applications can break the silos, go into multiple sectors, means that there's more opportunity for issues to arise that would need to be dealt with. Now, security is a very complex issue, and one of the things that I like to point out to people is that there is no one solution that's going to focus on provide a solution for all of the possible issues that can occur. In this diagram, I attempt to show just a few of the issues that people might need to think about. There's the issue of privacy, which is not direct security, but it is an issue that requires security in general. There's the issue of data longevity. How long is your data going to be stored? And if so, is there a likelihood that there could be a breach sometime in the future? There might be laws and regulations associated with the particular data that you're collecting and gathering. For example, medical applications tend to have specific laws that go above and beyond the need for simple security. They might need some implementations of higher level security to avoid privacy breaches, etc. And of course, then there's the issue of how do you prevent a security breach, how do you detect one that has occurred, and how do you resolve it once you know it has occurred, etc., etc. The point I'll make over here is that there are tons of issues that you need to take into account, and different applications will have different solutions for those. And we must remember to set our expectations correctly. In general, the issues of security risks can be recognized and understood, at least to the degree that we can plan correctly from the start. And that's the important point, planning correctly from the start. In general, again, you can detect and resolve most security issues reasonably quickly and efficiently with the kind of standard tools that people have been developing and providing over the years. You can generally, again, manage and control them with confidence in the methods that you might be deploying, because those are the accepted methods that people are in general are recommending or may need to be deployed across the board. But here's the important bullet that I think is essential to understand. You will never completely eliminate all security risk. We cannot expect perfectly secure applications. There will always be some vector, some target mechanism that we have not taken into account or perhaps has not been understood in the context of the particular application that you're trying to deploy, and that new vector will require the ability to detect it in ways that we might not have planned for, and you need to think about that and resolve them properly if and when they do occur. Now, what is secure enough? And there's an important point over here to be made, which is that you have to balance various security objectives. And these objectives are, in general, they're what I call 4 pillars associated with managing a security objective. Is the sender of the information and the receiver of the information properly authenticated? Does the sender know that the correct device is transmitting? Does the receiver know that the correct server is receiving that data? You have to make sure that both ends are properly authenticated. That's one pillar. The second pillar, which is very important, is that the network always has to be available. The sender and receiver have to be able to talk to each other. They have to be able to use the network. The reliability of the connection is very, very, very important. And then, of course, is the data trustable? Did the device transmit the data correctly? Did the device receive any control messages correctly? Did the server get the messages correctly, etc.? Confidentiality, that only the intended recipients receive that data. Nobody else gets it. The device gets the data that it needs to have. It doesn't get the data for some other device. And the correct server is accessed by the device to transmit that information to in the first place. What I show on the right-hand side is sort of the balancing act that we have to follow, which is that sometimes the act of increasing security can increase your costs, might take longer time to get to market, whereas if you were to reduce some of those security, you might have a lower cost, might be simpler to manage. On the other hand, your application may be more vulnerable, and therefore you would have to have perhaps a delayed risk factor or delayed cost factor of mitigating a specific breach that could occur. You have to balance those objectives. Now, in an IoT application, there are various places where you can manage that risk, that security risk. This diagram shows the chain of information. On the left-hand side, you have the sensors, you have the smart devices, the various hybrid technology devices that might be present out in the network, gateways that transform one technology to another, Wi-Fi to cellular perhaps. And then there are various transports that are being used, everything from short-range transports such as Wi-Fi to long-range satellite transports, and in the IoT world, including non-wireless transports are being used, and all the way down through the chain. You have the network infrastructure, you have the data connections where the data is being delivered, you have the host systems for that application, corporate networks where those servers might be deployed, what kind of access controls might exist at that point. And eventually, on the right-hand side, you see the human beings who might be receiving that data, or a process that automates the response to a particular data that is being received, or a control message that is sent back down the chain in the other direction. The point is that there is an element in the chain, and that every element in that data chain is subject to a risk of some sort. And the question then comes up, is a security breach going to affect just that one element, or potentially more? In other words, if you have a device that's been compromised and that data from that device is no longer trustable, could you assume that there's a process on the far right that can receive that compromised data and take some action that might be inappropriate? And the answer is it could happen. So you have to understand the various access points. Who has access to the data? Is a server properly protected? Is a server sitting on the internet from some other aspect, from some other network aspect which could be compromised? Understand all those access points, and then you need to design for that particular threat for your application. Again, I will emphasize that no one solution fits all applications, so you need to take each application and understand the specific issues that might govern the appropriate architecture of the solution you provide for security. Now, one of the other things that I like to make very clear is that the amount of security that you implement in a given application depends very strongly on what is going to be the impact of a particular breach. So this is sort of two axes of way of looking at it. I didn't take cost into account. I just said let's understand what happens if you take the bottom axis, which is that the consequence of a breach has little to no impact on the left, or a very high degree of impact on the right, and then look at the left axis where if there is a breach, very few people are affected, or very few systems or processes are effective, all the way up to the upper left where maybe all of the people associated with that application are affected in some way, shape, or form. So bottom left-hand in that quadrant would be no security problems, meaning if a breach has little or to no impact, if there are very few people affected, maybe the degree of security that I provide doesn't need to be expensive or extensive and doesn't need to be a fairly complex solution of some sort. I may not need to worry about encryption. All the way to the upper right-hand corner where if there is maximum impact, there might be some significant widespread damage because of a breach. Many people might be affected and, God forbid, some fatality could occur. Then I may want to be very concerned about my security solution, what I implement, how I choose to implement it, and maybe it might take some significant dollars to make sure that the impact is minimized in some way, shape, or form. Now, let's take some typical applications from the M2M and IoT world and see if I can fit them into this diagram and decide how I want to go forward. So if you look at simple data gathering applications, maybe it's, like I said, thermostat readings from a house or from a business where if the data is wrong, okay, I might take some incorrect action. Maybe my automated systems for responding to the temperature measurements might be inaccurate, but it's not going to have a major impact on a ton of people. I might want to make sure that its basic protections are in place, but I might not want to implement a very high degree of security solutions. On the other hand, on the extreme right-hand side, you can see that there is a food and water supply chain issue that I might want to worry about, where if my water supply is compromised because of a failure of information or some kind of problem has occurred, people can be affected, can have a significant impact, and maybe more than a few people will be affected if it's a larger, sufficiently large supply chain that I'm worried about. And things fall in between. So you have telematics applications that sort of are in the middle. Medical devices tend to lean to the right. Typical medical devices today, because you're not seeing a high degree of mission-critical medical applications being deployed yet, although that may happen in the future. And of course, typical medical devices tend to impact a few people in general, as opposed to, if a breach occurs, as opposed to a large number of people, et cetera. And obviously, the largest one that we are all publicly familiar with are all the financial institution problems that occur, credit card breaches, which have occurred. Very high degree of media attention has been paid to those, but the point is that in general that has caused a financial problem, but may not necessarily have caused a problem with human life issues to be affected as a consequence of a breach. You have to take your application, fit it into this axis. Then there are other axes associated with cost and resolution and capability of the solutions that you might have. Can the hardware support a particular implementation that you would like to do for security? Can it do encryption? Is it powerful enough to do so? You need to fit it into these various axes and then make some decisions as to how to go forward and what kind of security implementations you might need. Now, in general, the kind of things that you need to think about aren't just the kind of I'm going to give you some examples over here of where you might need to think through the kind of solutions that you have. I pick a couple of fairly well-known security reports that were done in the past. One was a study done at Rutgers University, which talked about the tire pressure monitoring systems being compromised and what kind of security and privacy vulnerabilities could occur. We were in the middle of providing a capability to a car manufacturer in this particular case, and they were very concerned about this particular issue. And we analyzed it for them, and we said, great, we understand that the tire pressure monitoring system could be compromised. There are simple solutions that you can implement, and they went ahead and did that. But the main point of that study was to recognize that the system could only take over a very short-range radio, and therefore it was not like it was going to take over all of the cars in a city or a state and cause some kind of a problem. It had to do with a specific car, and the impact of the breach was actually relatively low, meaning that if you compromise the data being received from the tire pressure monitoring system, the worst thing that occurred was that the display on your dashboard was incorrect. It didn't actually affect anything internal to the car. It could have, but it didn't, and the point was that simple encryption could have cured that particular issue and not have to worry about it. The right-hand side shows a more serious issue. At a Black Hat conference some years ago, a gentleman demonstrated the ability to take over a wireless medical device. This was an automated insulin pump, and he was able to demonstrate that the capabilities of that automated pump, which could be implanted into a human being and controlled by their smartphone, hadn't been sufficiently protected. And he was able to take it over. Again, it had to be a short-range transmission, so he could only have done it to 1 or 2 people at a time. But the outcome could have been quite serious, because if you start pumping insulin into an individual who's not expecting, whose body is not expecting that dosage, you could perhaps cause a fatal event. That was the point here, which is that few people affected, but the impact could be enormous on that 1 or 2 people who are affected. So you need to think through some basic security implementations to avoid that happening. They simply didn't encrypt the data, which would have been a fairly simple solution in this case, because a smartphone's relatively powerful, and the processor they had in the application could have supported those kinds of encryption capabilities. Now, consumer security and privacy are related to security, but they're not quite, not quite direct security issues. We have to keep in mind that most companies are overlooking the kinds of security needs for consumers that isn't just a privacy loss issue. There's some potential for harm, and we need to think about exactly what people are doing in this arena for consumer applications, which we need to think through from a security perspective. Some years ago, there was a report that internet-connected two-way baby monitors were breached, and people were basically encountering scenarios where people on the internet were able to access the radios and the cameras inside people's homes that were being used to monitor their children. And in many cases, they were able to actually talk back to the child, and that's not a good thing. This is the kind of harm that I think we need to worry about from a consumer application perspective. The fact is that most adults today in the consumer world don't understand the impact of a security breach, but now we're expecting kids to deal with it. There was a recent, in fact, I'll show you a slide on this in a moment. There was a product called the Talking Barbie, which had a security breach possibility that children would be expected to deal with that issue when really the fact is that adults don't understand some of these impacts. And we need to have very careful protection for consumers. And so people, and this is the point of this slide, which is that companies who are marketing consumer IoT products must think through the implementation of security during the design of their application with some kind of understanding, with an analysis of the consequence of a breach, and take that into account. The solutions must ensure reasonable general public safety along with some privacy expectations for those consumer applications, which I think is going to be extremely important to avoid the kind of media exposure that could lead to a black eye for IoT in general. These two cases that I talked about have already, occurred in the past, and they've already been fairly reported, fairly well reported. There was an article about various baby monitors. It wasn't just one company. There were 9 basic models and companies that were reported that were wide open to hacks that essentially exposed the children's privacy into the internet in ways that you simply wouldn't want to talk about, wouldn't want to have happen to the child. And of course, the application of the Talking Barbie, there were some security issues that this particular product allows the child to talk to the doll. The information is sent on to a server so that the doll could effectively respond to the child in appropriate language, appropriate ways for that question that was asked. The problem is that if it's an unsecured device, it can be taken over. If the remote server, which is being used for answering the questions, is compromised, then of course the wrong responses could be sent back to the child. These applications need to think through the implications of what could happen if a breach occurs. Now, how do we achieve end-to-end security? Okay, from our perspective, and I'm going to talk about this from an ARIS perspective, but it generally applies to just about anybody who might be wanting to consider a security application in the IoT space. There are 4 things. There's what we call network whitelisting, traffic segregation, anomaly detection through the use of analytics, and then of course multi-stage or multi-technology verification processes. Now these are sort of a general terms, and let me go into a little bit more detail about that. First will be traffic segregation. One of the things that we are very careful about is that we make sure that devices on our network cannot communicate with devices, other devices on the same network. The intention is that they are blocked off from each other. So a device on our network cannot communicate with any other device. And then, of course, public access to our devices is also blocked. So what we're doing here is preventing, the problem that can occur if a single device gets compromised. Can that device be used to compromise other devices? And the answer is no. We try to prevent that as best as possible. As well as the public access is blocked. So can a remote mobile out in the field compromise the device in our network? And the answer is no. We block that. We make sure that it's only going back and forth to a specific application. Then you have the concept of a network whitelisting. In other words, the access control should be restricting the data to and from the device. So at the core, at the network itself, we want to make sure that the applications that are allowed to communicate with a particular device are the only ones that are allowed to communicate with that device. And then when that device transmits data, it is delivered to the correct application. It's shown on the right-hand side is application 2 in this particular example, where it doesn't go to somebody else. It doesn't go to the wrong application. It only goes to the applications where the M2M or IoT purpose is being served here. And anything else, all other communication, all other control messages are blocked. The idea is you start with a known connections that you require and open up as you need to. You don't, this is a traditional security approach here, by the way. You open it up as you need to, not because you start by opening everything and then blocking what you expect might be an issue. You start by only opening up what you know you want to have happen. The other thing about device anomaly detection, which I think is extremely important, is that you have to build some intelligence into the data gathering system. One of the nice things about M2M and IoT is that the patterns of data transmissions are relatively regular. You can monitor that traffic. You can see the patterns that it's expected to send, and you can baseline that communication. And once you have that normal pattern occurring, then you can monitor that for future breaches, meaning that if that pattern changes, something has occurred, whether the device firmware got changed, or it got breached, or a security breach event took place, or maybe the application server on the customer side was hacked and it's now sending control messages that it shouldn't. So monitoring that traffic pattern and appropriately setting alerts such that changes can be reported allows you to do detection. And one of the things I mentioned earlier is that detection is extremely important. If you don't know you've had a security breach, then how do you resolve it? So you have to detect the possibility of a breach. And M2M and IoT is simpler in one regard in general. And I'm talking here about non-consumer IoT applications, of course, that you can see the patterns much more normally. And if you see a device that is misbehaving, you can perhaps shut it off. If it's a critical application that you want to be concerned about, you can have automated shutoffs that prevent that device breach from affecting either the application or other responses to those applications that you might not be expecting to have happen. So if you get some kind of a problem where the information doesn't meet the pattern, you block it. You make sure the application is not affected. And finally, the ability to do what I call multi-stage verifications. This is a very common thing that is being implemented at a large number of sites on the internet, two-stage or multi-stage authentication, where information is sent along one channel, but maybe messages and control messages are sent along a different channel. In the case of the implementation that we're looking at, this is an example for firmware over-the-air updates, where the installer can download, an on-device installer can securely download the image from a server, but then the server also sends a separate out-of-band message to applications on the SIM, which tells the device, yes, this particular download that you received is valid. The implementation of that update request is correct, and therefore proceed. The architecture basically provides this level of security. You could have a scenario where the OTA server could get spoofed and the malicious software could get downloaded, but if the IoT platform itself doesn't send that key properly to the SIM, the software and the system will block the update. This is a traditional approach taken in many verification systems today, and we believe that implementing this in an IoT approach, IoT application would be the best way to proceed. And so we're doing this, and this is something that we have decided it makes a lot of sense for applications that have a high degree of compromise, or that if the action you're taking, in this case a firmware update, needs to be verified very securely. So in general, let me summarize. You can do things that you can take that security strategy and implement it in different locations. You can implement it on the network, on the wireless network. You can implement it in hardware and software. You can implement it in the application itself. You can monitor to find out whether or not breaches are occurring, and of course over-the-air updates to be able to do changes to fix any kind of problem that might occur. Now, the important point I want to make over here is that none of these necessarily are the only solutions you might want to implement. You might want to pick and choose based, again, on the strategy associated with the kind of problems that a breach might cause for that applications. What is the impact of that breach, and then decide which one of these you want to implement, maybe more than one, and maybe you need to have a complex security solution if the impact of a breach could be much higher than you would like. So let me give some more thoughts, which I think are very important. First of all, I think that security issues could become a barrier to IoT adoption if you're not careful. We have to trust the applications, and that trust in the data and the content is very, very important. We need to prevent, we need to detect, we need to respond to a breach, and we need to resolve the issues of a breach. And these are all important, particularly at scale. Once we get to the point where lots of IoT devices are deployed and many, many devices associated with an application are in the market, then the consequence of a breach could be a problem to resolve if we don't take the design issues into account up front. I think the other problem that I would be very concerned about is the fact that if there is a high degree of impact and the appropriate media attention to a particular IoT application is not good, we're going to have an impact, and we're going to see an impact to IoT adoption where we need to be concerned about that. And therefore, again, one of the concerns that I've always been very careful to identify is that we need to make sure that devices and applications that are deployed in the market conform to the right degree of security, such that an outcome of a compromised device or a compromised application does not cause a serious problem. The backlash could be very, very bad. Today, IoT security is still an afterthought. 3 or 4 years ago, it was even worse, but it is changing. We must architect and implement solutions during the design phase of these applications, particularly, as I mentioned, for very highly impactful applications. Anything that could have a serious impact on because of a breach should be something that we worry about, and we make sure that the security implementation we do is as good as we can do for that particular application, or perhaps a little bit better, just to take any possibility into account of future issues. Reasonable IoT security is possible. I think if we can implement the best security practices that we know of today at all points in the chain, it will be a good thing in general for IoT, not just for the particular application. Again, I will emphasize that it will not be perfect. We must plan for updates, and I can't emphasize that enough. One of the things that we have had difficulty with some of our customers is that because of cost issues, they may deploy an application that can't be fixed. Well, again, if you have a large number of application devices deployed, the act of fixing, if it requires a physical change out or requires a human touch to basically fix the firmware or change the firmware or resolve the compromised device, then you're going to have problems of cost that could cause a serious issue for that particular deployment. And that cost issue could be prohibitive to getting a successful application out in the field. We are basically considering, recommending strongly that OTA update possibilities exist in all IoT devices as best as possible, because if you have a problem, you can go and fix it over the air and not have to try and touch it later on, because that could cause a serious cost issue to prevent that device from being repaired or fixed out in the field. One other thing that I should touch on very quickly is the concept of privacy. I think that if you look at what is happening in the sort of the media today, is that people are getting desensitized by a large number of widely reported failures. I'm going to take the credit card industry as an example of that, or sort of the retail industry, online retail industry, et cetera, as an example of that, where there have been tons of breaches. And people have seen these breaches. People have recognized the first few as being very important, and then after that, when a follow-on breach occurs, that somewhere else, there has been less media attention, and people sort of get desensitized to that. Oh yeah, one more of these, so to speak. There were very well-publicized breaches at retail stores due to credit card information being recorded some years ago, but what people don't realize is that a lot of companies have been breached in that exact same manner, but they have not received the media attention that they could. The other thing which is very interesting about privacy in general is that there seem to be I see some generational differences happening. To this current generation and the next generation of children that are coming along, which seem to want to have no problems with putting their most private information up for public access on the traditional chat sites and social media sites. There seem to be a natural reaction to people, for people, to not worry about privacy, their personal privacy, et cetera. And I think that's an issue that we need to think about, and because I think personal privacy, will indeed be something that will cause a change down the road that we may not expect to have happen. And we need to take that into account, the fact that people may not care as much about personal privacy as much in the near future. My final slide, I will basically talk about the fact that I mentioned that security will never be perfect, and there is an example right here of a technology that we've been relying on for encryption, where the ability to decrypt has always been considered an extremely unlikely possibility for a sufficient degree of encryption. Well, as you can see over here, there are efforts going on to try and do computations which could cause some of the encryption mechanisms we use today to become less useful in the future. So the point is that no matter how much encryption or how much security we think we're going to implement, it will not be perfect. And by definition, we need to worry about that. We need to worry about the fact that a device could get impacted in the future, and therefore how will we resolve that particular impact that could occur. Okay. That was my presentation over here. I will leave you with two other pieces of information on this slide. One is the website for my company if you want to get more information about IoT and how we implement it, and the other one is the website for the Mobility Development Group. I would love for people who are listening to this webinar to go to the Mobility Development Group website, check it out, and consider having your company become a member. It is providing some important information into the cellular industry, particularly the CDMA, LTE, and the transition from the CDMA technologies into the LTE industry. If you have an interest in joining the group, please contact Kevin, and we will get you the information forms on how to become members. Kevin, I'm going to hand this back to you, although we have a few questions that I can address if you want to touch on the Mobility Development Group a bit, and then I will address the questions perhaps.
Okay, sounds good. Just a couple things to wrap up. Thank you, Z, again for speaking today, and thank you, Eris, for hosting the webinar today. Thank you, the attendees, for joining us as well, and we hope you found the webinar helpful and engaging. We do have our next webinar scheduled for July 12th at 9 a.m. Pacific. It's titled Enhance 911 Locating Callers. It's FirstNet update and how E911 and FirstNet will change public safety communications. And that will be presented by Andy Siebold of Andy Siebold Incorporated. And I'd also like to remind everyone who is a member, you are invited to keynote speak at our webinars and provide articles for our newsletters as a benefit of your membership. If you have any suggestions on webinar topics that you would like for us to present, please submit them to us as well at info@mobilitydg.org, or you can submit them online on our website, mobilitydg.org. If you are interested in becoming a member, as Z said, please fill out the application that is located on our website as well. Z, if you wanted to go ahead and
let me address a couple of the questions I've seen so far. First question was, is NIST or NIST Level 4 user authentication required by the IoT and M2M markets? And if so, how much will customers be willing to pay for this level of security? That's a darn good question. Again, as I mentioned, almost every application and every market is going to be require a different degree of security. So could an application require significant user authentication, a significant high level of user authentication? Yeah, it certainly could. But it depends. If it is a financial application, perhaps, or if it's a medical application, I can see the need for having user authentication that is significant. Is it required in general for all the IoT markets? No. A simple data gathering sensor that is monitoring air quality or temperature or something like that probably does not require significant user authentication unless that data is being gathered in the context of where it could have some impact on a system that sends back a control message, perhaps, to either change a temperature setting automatically, a thermostat, control a HVAC system automatically, or send back some control message that is based on the incoming data. Then you might want to worry about authentication, but again, it may not be to the required degree that a financial application might want. For example, electrical vehicle charging stations that use credit card swipes, there are a number of them on our network, and the degree of authentication you'd want there is much higher than for a simple data application, because you want to validate the credit card number and you want to validate that the correct credit card was used, etc. The correct user of that credit card is in fact requesting the card to be charged, etc., etc. So it depends on the application, unfortunately, and there's no simple one yes or no answer to this. It is you got to evaluate the specific application, what could happen if a breach occurs, and therefore should a significant user authentication be required or not. The second question is it possible what type of security mechanism can be used to protect security in IoT wireless networks? Is it possible to use AES or RSA type of power-hungry encryption schemes? Yeah, certainly. It depends. Again, unfortunately, in many IoT applications, the remote device might be battery-powered. And in that application, I would be concerned about something that requires a high degree of security or a processor that requires a high degree of security software to be implemented in that particular application. Those processors will be more power hungry, and therefore you're going to have scenarios where the trade-offs between power available from a battery, perhaps a battery-powered application, and the trade-offs associated with what kind of encryption schemes you can use on that device are going to be important to consider. There are applications which may have a power source that doesn't cause a problem, and therefore a power-hungry encryption scheme may not be an issue. Again, it's just going to depend, and the things I can think of is that the implementation may be such that the device may operate under power under certain conditions, or maybe under battery power under other conditions, and those conditions may dictate the choice of a security implementation that changes. For example, if it's a battery powered or not, you might implement a slightly different scheme and make sure that the appropriate degree of security is implemented, security encryption is implemented. This is a tough question to answer from the perspective of every device. It has to be, or every application, it has to be very specific to the kinds of applications and devices you're deploying. I think those are the only two questions I've seen so far, Kevin. Either I was perfect in explaining to people what we should do, or they're all confused by what I said.
Okay, no, good job. I guess we can wrap it up now.
Yeah, let's do
Again, more information on the archive of this webinar and information on our next webinar will be available shortly via email and on our website and through our social media outlets. Again, thank you everyone for joining. And thank
hey, one more question came in, Kevin. Since we've got a little bit of time, maybe I'll address this one. It's not really security related. It says, what is the biggest challenge ARIS has as a company? I think that let me just address that because it is relatively relevant to this this webinar here. I believe that security and scaling are the two biggest issues facing not only us as a company, but any company that's deploying an M2M and IoT application. And I mentioned both of those because they are related in some degree. If a security breach occurs in a device that is not very highly scaled, meaning that not a lot of devices have been deployed out there, then you have an opportunity for fixing it without having a major financial or other headache on your hands. On the other hand, if the scaling of that application has been such that it has grown dramatically and there are hundreds of thousands of devices out there, then you may have a scenario where a security breach would require some significant attention application. So I believe that is a general challenge, not only for us as a company, but for any customer who's deploying an IoT and M2M application, is worrying about what happens at scale, what kind of security issues can occur. And the security issues aren't just, for example, a breach of a device. It could be that a device is running away, meaning that it is transmitting more than you'd expect, or maybe it's causing a problem for the data servers on the host side, receiving too much data from a device that's no longer being able to be controlled. All of those issues of scale and all those issues of security are very, very important for us in the future. And I think that if you look at the numbers that people are predicting, in the billions of devices in the next 5 or 10 years, we need to take these kinds of issues into account, because runaway devices or insecure, breached devices could be a significant problem to the industry as a whole, not just to ARIS. So that was it, Kevin. I'm sorry I interrupted you over there, but I think we can probably wrap up at this point.
Sure. No, it looked like there was one more question.
Oh, there's one more question popped up. Ah, very good. The next big thing or step for IoT, do you think 5G will solve all the problems? That's a darn good question. 5G has got a lot of hype going for it for obvious reasons, but it has an interesting, I guess I will call it, a set of specifications and requirements, some of which have to do with IoT. Obviously, 5G is going to have the high-end solutions, which are the requirements that are being set for being able to do gigabit per second transfers at very, very, very low latency. 1 millisecond latency numbers are being thrown about. But they're also talking about implementing devices at scale. The important thing about M2M and IoT devices in 5G is that they are trying to consolidate all of the various technologies under a single umbrella term called 5G. So even the low-power networks, such as the NB-IoT and the various proprietary technologies, could become a part of 5G deployments. And those would have a good outcome for M2M and IoT in general. On the other hand, 5G is still at least 5+ years away. Yet not the announcements from carriers notwithstanding. They're doing testing on the high-end stuff at high frequencies, but M2M and IoT is going to continue to be the sort of the low-end communications usage on 5G. And those technologies are not yet part of the 5G umbrella that is being tested today, although individual technologies are being deployed and tested, such as the low-power wide area networks, NB-IoT, et cetera. So yeah, there will be a definitive change in the right direction in the next 5 or 10 years. A lot of things will evolve, but on the other hand, making sure that 5G works correctly for all IoT devices, I think it would be a little too premature to discuss that in general today. Here's another question here. How is the security defined for connected devices? Currently, each sector has its own security standards. Will there be any future convergence point for the same? Darn good question, and I think that there will be. It's going to take a lot of effort. There are efforts to define security standards built into the work being done by the One M2M. It's called One M2M, O-N-E M2M. Working group, which is a group that was established by the various standards development organizations around the world to set a core group of architectural standards for M2M and IoT in general. And one portion of the work they're doing relates to security. And I think that that will perhaps be the closest that I can think of somebody who's trying to converge the security standards into one location. It has to be done carefully because, as mentioned in the question, every sector probably has its own set of requirements that may or may not be covered by the One M2M security standards. For example, the medical industry, I'm sure, has its own set of standards that are completely different from another market sector, and those particular implementations of security are going to need to take that into account. So it is entirely likely that even though there may be an umbrella standard that tries to converge many of these other standards, you will have to have specific implementations that deal with the local, the application-specific or the market-specific standards that may be needed, independent of any overarching security standards that bodies like One M2M are trying to implement. I think we should treat that as being out of time so far, and let's address any other questions that come along and through email later on, Kevin. It's now almost time for the webinar to end.
Sounds good. Great. Thank you, everyone, for joining, and be on the lookout for emails shortly with archives for this webinar and information on our next webinar. Thanks again, Z.
Thank you, Kevin. Bye-bye.